We can do this. Find the volume of the figure. All right. So volume of a pyramid is 1/2 the base times the height. Remember, big B is the area of that base, right? So that's the tricky part. Hopefully my screencastify works today. Volume equals 1/3 the area of the base times the height. So that B is that whole area of the base. The area of a square is going to be 4 times 4, or 16. So that big B is going to be 16. And then I've got the height, which is 12. So the big B is 16 because that was 4 times 4. Find the area of the shaded base. And then the height is 12. So if I do that in my calculator, 1 divided by 3 times 16 times 12 is going to be 64. So I think those should be the answers. So if we go to question 2, what is the surface area of the following shape? So the surface area is a little bit different. 1/2 LP plus B. 1/2 LP plus B. So surface area equals 1/2 LP plus B. So we've got to know what all of those things are, right? The L is that lateral or slant height. So the L is the slant height. So that's the L. So that's 16. The perimeter is the perimeter of the base. So that's 11 times 4. 11 plus 11 plus 11 plus 11 plus 11. So the perimeter is going to be 44, the distance all the way around that square base, right? So if I'm the supervisor at the Louvre and I'm walking around that square base, that's the perimeter. And then the area of the base, that big B, is 11 times 11. 11 times 11. This one was 11 times 4. So the difference between the P, the perimeter, and the B, the base, is 1 is the distance around, and 1 is how many tiles it would take to cover it. So once I have L, P, and B, which are definitely significant things to make sure you know how to do, then I'm going to multiply those 3 things together and then add in the area, the area of the base. So in a calculator, I do 1/2 times 16 times 144, not 121. Just kidding. Let me clear that. 1/2 times 16 times 44. So that's 352 plus 121, or 473. How do we feel about that, guys?
I know how I got it wrong.
Okay, what'd you do wrong out of curiosity?
For area, I didn't see that it said, I wasn't paying attention, and I thought it was just the area of the 16, like of the slant height.
Gotcha. It'll be good to be able to post this video because I know a couple people who are taking the SOL. I mean, it'll be after the fact, but they were stressing out about these questions too. How much glass is needed to manufacture 1,000 paperweights? So when I'm looking for the glass to make that, and it is solid, do I want the volume, the lateral area, or the surface area? So lateral area is a good guess. If I was going to cover or paint the sides, that's what lateral area would be. If we're going to make one, like I've got actually, this is like a mold. So you can put like resin in here and it will make a pyramid. So if I want to pour the resin into this mold to make a pyramid, is that volume, area, or surface area? I want to fill it. Volume, right? So some of these questions are hard because you got to translate them first. Like just tell me what equation I need to use. So to make this glass pyramids, we're going to do volume as 1/3 base times height. Excuse me. So volume is 1/3 the big B times the height. Again, that big B is that area of the bottom. So that big B is going to be 3 times 3. So V equals 1/3 times 9, because 3 times 3 is 9. And then the height is 4. So you do that multiplication, 1/3, 9 times 4, and I think you get 12, if my mental math is good. And so the temptation is to put 12 here, right? How many paperweights do we want to make? 1,000. So we've got to multiply that by 1,000.
Next question.
Yeah.
I kind of wrong.
Did you?
Yes.
Let me double check it. Did you put a comma or no comma?
I didn't.
Okay. I wonder whether I just need to add it in without a comma then. That's the problem with these like fill in the blank ones. If you don't key it in exactly the way it's supposed to be, it'll count it wrong. So let me double check on that. That one's number 3.
Oh, wait, no. I just forgot 0. I just looked at it.
Oh, okay. I call those silly mistakes. I make them all the time. It makes me crazy when I go back and I'm like, oh, that was so dumb. Chloe's working on a project for her history class. She knows the volume of a large pyramid in Egypt is a little over 2 million cubic meters. That is a lot. She also knows that the base is 53,000 meters. She needs to find the height of the pyramid. So if she knows the volume, we've done volume a couple of times. So volume is 1/3 the base times the height. I know the volume, so I can put my 25 or my 2.5 million here. And I know the base. So that's 1/3 times 52,900. And I want to know the height. So the first thing you want to do is kind of clean up your equation, right? So we'll put this part in the calculator and simplify that. What's 1/3 of 52,900? I got 17,633 and a third times the height. So now you divide by that. The numbers are big, but it's still just a 2-step equation. So 2,596,100 divided by 17,666.3 or 600 is 147.2. And that would be meters. Does that sound good? Morning, Theodora. How are you? We're looking at the pyramids puzzle piece. I reopened all of those puzzle pieces for today. We're just going to kind of do a work day today to catch up and make sure everybody has good grades for the end of the term. A pyramid has a... Say it again?
I had a question about the sphere one, because I think one of the questions might have like a mistake.
Oh, let's go over that one when we're done here.
Okay, thank you.
Yeah, absolutely. A pyramid has a height of 9 yards and a volume of 96. So I'm going to use my volume, right? Volume equals 1/3 the base times the height. So my volume is 96 cubic yard. Which of these are possible dimensions for the regular base? Oh, so this is kicking it up a notch a little bit. So I'm looking for the base and I know the height, right? So we're going to do the exact same thing here. We're going to multiply 1/3 times 9 and get 96 equals 3b, because 1/3 of 9 is 3. And then we're going to divide by 3 and divide by 3. So the area of that base has to be 96 divided by 3. That's 31, isn't it? I'm reaching for my, or 32. 96 divided by 3 is 32. So now the question is, which of these could be the area of the base? So I know I've got a square base or a rectangular base. I know the area has to be 32. So what do I have to do to the length and the width? We got to multiply them. So if it was 6 by 7, that would be 42 yards, because 6 times 7 is 42. If it was 2 and 18, that'd be 16 yards, because 2 times 8 is 16. 5 and 8 would be 40, because 5 times 8 is 40. And then 4 times 8 is 32. So which pair of sides match our target area? So that's kind of it just kind of causes you to think about it a little bit more. Do we need to go back and look at any of those? Did anybody submit? Are there any problems I need to look at? Like with the answer key?
Answer number 4 was wrong. The Cleo was not a quadrant one.
This one?
Yes.
What did we get? We got like 142 point something?
No, 147.2.
147.2. I thought there was a 7 and a 2. I just couldn't remember which way they went. So let me stop sharing for a minute. B equals 4/3 pi r cubed. So if I'm given the 18, that means the diameter equals 18 and the radius equals 9, right? So 4/3 pi times 9 cubed. And it says use 3.14 as pi. So 4 divided by 3 times 3.14 times 9 to the 3rd power. I got 3,052.08. So I'm going to do 3,052. And then if we look for surface area, 4 pi r squared . 4 pi r squared. We just got to put that in the calculator. So I got about 1/3 of that. 1,017 if we round. Make sure you know how to put them in the calculator, because sometimes knowing how to set it up and then programming the calculator are two different things. Find the volume of the following shape. So this is half a sphere. So we're going to use the sphere formula, but we're going to divide it in half because it's a hemisphere. So sometimes I don't remember these. Volume 4/3 pi r cubed. 4/3 pi r cubed. And we're going to use 3.14. So 4/3 pi and then 15 cubed. But then at the end, we're going to divide it by 2 because we only need half of that volume, right? It's like half a grapefruit. So 4 divided by 3 times 3.14 times 15 to the third power is 14,130. And then divided by 2, you get 7,065. The trick here is to divide by 2 because it's a hemisphere.
Wait, so do we put the commas in?
It shouldn't matter.
Okay.
Like, hopefully Miss Williams put these quizzes in and I liked them, so I'm using them. But this is the first year I've used them, so I don't know if you need the commas or not. If you get it wrong because you put or didn't put it in there, I'll just add the answer choice, just like I put in with the last one, the 147.2, and then it'll count it right.
Okay, yeah.
All right, Theodore, this is the one that you wanted to talk about. Question 3. The Science Museum gift shop sells lollipops that are made to look like planets. Each lollipop is shaped in a sphere with a radius of 12 millimeters. Meriwether wants to buy all 8 planet lollipops. So we want to buy all 8. What is the new volume of the candy that she will buy? So just to make sure I haven't forgot the volume formula, lollipops are usually spheres, so 4/3 pi r cubed. 4/3 pi r cubed, and I know the radius is 12. So 4/3 pi 12 cubed, but then I want 8 of them. So at the end, instead of like in the hemisphere, we divided by 2 because we only wanted half a sphere. This time we want a set of 8, so we've got to multiply by 8. So you got to put all of that in the calculator.
There's where the problem came up because I had the volume and I got that correct. But then when you multiply by 8, and I did it like a bunch of times in the calculator, and still got the same number, it's saying that's wrong.
So did you get 7,234.56 for the volume?
Yes, but wait, no, because it says 7,235 is correct.
Correct. So did you multiply 7,235 or did you multiply that by 8?
7,235.
I bet they multiplied with the decimal. So let's do this times 8. If I multiply this, I get 57,876.48, which would round to 57,876. If I multiply this by 8, 7,235 times 8, I get 57,880. So let me write those down. We'll review the last 2 for those who want to review those. And then once we're done, I'll check and see which answers are in there. 57880. So did you get 57,880? Is that what you put in?
Yeah.
Did I? And then I never did. That happens sometimes. Second, third block come and then I forget to do stuff. All right, so let's look at question 4. Don't let me forget that I need to go back to question 3 because I want to make sure I do it today. Ariel is filling a giant beach ball with air. The radius of the beach ball is 30. What is the amount of plastic needed for the beach ball? So if I'm doing the plastic, is that surface area or volume? This is my beach ball. The air the air inside it is the volume, and the plastic to make it is the surface area. So 4 pi r squared. So here I want surface area of 4 pi r squared. So 4 times 3.14 times 30 squared. And then round that to the nearest whole number. Okay. Do you have a chance to do that? I'm not going to do that one in the calculator right now. I'm just going to go to question 5. We can go back if we need to. Air is leaking from a spherical shaped advertising balloon at a rate of 26 cubic feet per minute. Okay. So that's like minus because it's leaving, it's leaking. If the radius of the balloon is 7 feet, how long would it take for the balloon to be empty? So I'm talking about volume. Round your answer to the nearest minute. All right, so even the hint says find the volume first. So we want to find the volume of the sphere. Volume is 4/3 pi r cubed because volume is always to the third power. 4/3 pi times 7 cubed. So let's find the volume first. 4 divided by 3 times 3.14 times 7 to the third power. I got 1,436, right? And that's feet cubed. So if it's leaking at 26 feet per minute, and I want to know how long it would be for it to be completely empty, I want to divide by 26 feet cubed per minute, and that's going to leave me with minutes. So 1,436 divided by 26 is going to be 55.2 minutes. Round your answer to the nearest minute. So even though, and this is where real life gets tricky, right? Even though our rule for rounding is 2 rounds down to 55, if it only leaks for 55 minutes, is there still air in the balloon? I think you need to round this up to 56 because it won't be completely empty at 55. It'll still have, 0.2 of a minute worth of air in it. It won't be very much air, but it'll be a little bit. It's kind of like if you're talking about people and you get 55.2 people. I can't have 0.2 people. I'm not going to cut somebody in half and just use their 2 arms for a 0.2 people, right? You got to round up to 56 people. It's kind of a morbid thought. But let me check that one too, because I think it should be 56 and maybe Miss Williams thought it should be 55.
There's that too.
Yeah.
I answered 55 and I got it right.
Did you?
Yeah.
Okay. I think I'm going to add both of those in there because it really should be 56 because you can't have. That is the rounding rule, and Miss Williams is all about the rounding rules. However.
Also for number 3, I still got it wrong.
You still got it wrong. So let me check. There are 1, 2, 3, 4, 5 answers already in there. So let me check. 5, 7. So 3, 70, 70, 76, 70, 76. All rounding issues. All right. We should be doing question 3 now. If you refresh our page, you should not be able to answer one. then they look at them for 5. All right. Theodore, thanks for bringing that number 3 questions back to my attention. Sorry, I had to pick one when I was coaching you.
Yeah, no, not my look.
No, this is a problem with them forcing us to create all of our own intentions and stuff. Is that like there's not enough time to make them perfect, which is sad. We try. So I'm always appreciative when you bring my attention. So I just want to go back here. The rest of the class, pretty much, I want you to work on these. Work on this district assessment, but I do want to bring your attention to the quadratic notebook, okay? So before I do that, in your courses, because next week, this course is going to evaporate, right? It doesn't go away. So when you go into your courses, you can see my screen, right? Sharing. When you go into your courses, your current courses are here. So next week, all of your current courses are going to go away. But this class and all your other classes will go into this archive folder. So in this archive folder, I can see my class from last year, I can see them 2 years ago, I can see them 3 years ago. Like I have a ton of archive classes in here, right? This is where you can find your Algebra 2 notebook after next Friday. All right. So when it goes away, you can always go into your courses and into our archive, and you can still find our class. So what I'm going to do is I'm going to unpublish everything, so you won't be able to see really anything except this quadratic folder. Okay. The reason I'm going to do that is at some point you might want to go back and practice some of these things. In fact, I would encourage that at the end of August, beginning of September, before you start Algebra 2, to go back into the quadratic notebook. So if you're not here already, go into Schoology, find that quadratic folder, and then open up this assignment. You can also go to the home page, right? And open up the assignment over in the to-do list. It'll stay in the to-do list until next Friday. But I want you to make yourself a copy of this so it's in your Google Drive. So you'll also have it there. So click on yours different than mine, I know. But click on the Google Doc so you can open up that assignment. I'm just going to open it here so it's easy to see. It looks like all of our regular interactive books, right? It's quick linked. These are going to be like topics for the first 2 to 3 weeks of Algebra 2. If you want to get a jump start on it, you can click on factoring. And it'll teach you there's videos here to watch. There's practice. There's answers to practice. And then there's exercises that you can do to make sure you know what you're doing. Okay. This is these puzzles are a great way to factor. There's a direction right here. You want video, and then there's the answers. Everything you need to kind of brush up, teach yourself, and remember algebra before you take Algebra 2. It's going to be important that you do that. Okay. We had more school next week. I will go over some of this with you. We might probably look at it on Wednesday when we're all together, just because I know you'll be taking you well on Wednesday, so I won't see you. If you want to look at this and think office hours, I'll have office hours on probably Monday, Tuesday, and Thursday and Friday. Maybe I'll have one Wednesday too, but next week I'll try to have office hours almost every day in case somebody wants to come in and talk about any of this stuff. Okay. Any questions on the quadratic notebook? It's a super great resource to get you ready for Algebra next year. We just run out of time to kind of go over it. With that being said, it is 8 o'clock. We have 15 minutes left in class, and I kind of like to let that be your time. So if you want to do anything else, we can go into a paragraph together, you and I, or a couple of people if anybody else wants to do that. But I'd like to give you the last 10 minutes to just work on these green puzzle pieces. Look at that quadratic notebook you want. Definitely works this division assessment. Sound like a plan? All right. If you want to go to a breakout room where we need to talk about anything specific, just message me in the chat and I will open that up. Otherwise, the rest of the class is yours to do as you see most productive for you personally.